Okay, so this is the calculator section. So I'm going to show you at the end a way that we can do this question without really knowing anything other than how to cleverly use a calculator. But normally, these kinds of exponent rule questions appear on the no calculator section where we wouldn't really be able to kind of cheat it a little bit. So we need to memorize the rules. So that's the key here, is these are things that are worth memorizing. We just need to know these rules in case they come up in the no calculator section so we don't give up on points where they're not that hard. It's mostly hard because most people don't know the rules. But if you know the rules, this is actually pretty quick about how we're going to get this answer. So we need to focus on what they tell us here. So I'm going to rewrite what they told us. A to the negative 1/2 is equal to x. And we need to be able to convert what we have here into something more meaningful, because negative 1/2 as an exponent doesn't make a lot of sense to me. And it doesn't make a lot of sense from an algebra standpoint. So here's what I would do. The first thing is knowing how to deal with negative exponents. What most people do is they wrongly think that negatives in an exponent can somehow come out of the exponent. So choices like B and D, I kind of know that those are not going to be right because the negative isn't going to just magically appear out of the exponent. If it's in the exponent, it tells us something about the number, but it's not a positive and a negative in the way that we normally think about positives and negatives. What it does is it actually moves the A term as if it were in a fraction. So let's pretend for a second that this is a fraction. It would be A to the negative 1/2 over 1. To get rid of a negative, what we do is we move the term to the other part of the fraction. This also is going to work if we had something on the bottom, we could move it to the top. But in this case, what it means is that we really end up with A to the 1/2 on the bottom of a fraction. 1 over A to the 1/2 is equal to x. And so that gives us a little bit better of a rule because negative exponents are kind of weird for us to think about, but hopefully we remember that a fractional exponent gives us another thing, which is it basically substitutes as a radical. So this is going to be 1 over the square root of A. So the rule in general, let me do it this way. So if I had y to the 3/2, that's the same as the square root of y to the 3rd. So the root is on the bottom, just like the roots of a tree are on the bottom of the tree. And then the top part of the fraction is still an exponent, but it's an exponent like on the thing now without the root. So basically, we don't write the 2 there because it's a square root, but it's kind of hidden in there, and that's where it's coming from. If it was the other way around, if it was y to the 2/3, that would become the cubed root of y squared, right? That 3 becomes the root, and the 2 stays as an exponent. That's the rule. And so that's happening here because what is this root? Well, square root means it's a 2 as the root, and the exponent on the A is 1. We don't really write it. We don't write either of them, but it's there. That's kind of what it is. So now what would you do? Well, now I can kind of solve for x in a very traditional way. I would square both sides to get rid of the exponent. And so that would be, or get rid of the root rather. So that would be 1 over a, because 1 squared is 1, and the square root of a squared is a, is equal to x squared. And then there are a couple things you can do, different ways to think about it. You could make the x squared into a fraction and cross multiply and all that. But the way that I learned this is if we've got two fractions equal to each other, we can just kind of flip them around. So I can flip this so that I have a on the top is equal to 1 over x squared. And of course, I wouldn't write a over 1, I would just write a. So a is equal to 1 over x squared, which is choice C, which is the answer. Okay, so this may seem complicated, but we're really just using two rules that we really need to memorize. That's the negative exponent rules and the fractional exponent rules. But if we're not super certain on those, you can still get this right. You can arithmetize this question. Just be careful and use your calculator. We would not be able to do this easily on a no calculator section, but we can do it on the calculator section. So let me rewrite what I had here, which was a to the negative 1/2 is equal to x, and this is the arithmetize version of this. So the only rule that we got was a has to be greater than 0. So I'm going to pick a weird number on purpose here. I'm going to pick that a is equal to 3. And so what that lets me do is then plug 3 in and solve for x. So I need the calculator here. 3 to the negative 1 divided by 2, using some parentheses, gets me that x is equal to 0.57735. And there's more, but I'm just cutting it off there. Now, remember how arithmetize works. We know that a is 3, and we want to take our x that we just found, plug it into these choices, and see which one gets me the a equals 3 that I started with, right? Because we're trying to solve for a in terms of x. So once again, I know b and d are not going to work even without plugging them in, because those are negative numbers and a is a positive number. So we can't have that. So that's not going to work. But if I tried choice a, that would be the square root of x, which would be the square root of 0.57735, which I know that's not going to work, but I'm just going to do it anyway. 0.57735 is 0.7598, which does not equal 3, which is what I need it to equal. So there's a being proven wrong. Whereas choice D, 1 over x squared, would be 1 over 0.57735 squared. So 1 divided by 0.57735 squared is 3.00002798. So it's not quite 3, but there's a good example where we rounded at some point, and when we plug it back in, we're going to need to round again. But it's so obvious that that's right, because it's so close that we would know that we've got it right, and sure enough, C would be the answer that way as well. So there are 2 lessons here. The first one is you just got to memorize these things, because it's much easier, I think, and there will be cases where you have no choice but to regurgitate the rule without the benefit of a calculator. However, the bigger picture strategy that goes beyond this question is that arithmetize is really, really powerful. And if we get comfortable with it in simple situations, we can trust the same process in more complicated situations, which is what we have here. We have weird numbers. We have weird operations that we're doing that our brains aren't good at handling on their own. But if we find ourselves on a calculator question where we don't need our brain to do the arithmetic, we have a lot of flexibility with arithmetize. Basically, any time where you have variables that you don't need to solve for, variables that are placeholders, you can arithmetize. You can pick numbers for those placeholders and see what happens, and that will almost always work out. There are exceptions, but if you were stuck, don't worry about the exceptions. Try the strategy and see if it works. It might get you unstuck, and if it doesn't, oh well, you're in the exact same place you were anyway. So you want to be able to reach for those strategies when things get weird. You might save yourself some points, and it's better than just staring at a question, hoping that some rule comes to mind that you didn't bother to memorize. So we got to be resourceful. We've got to try different things. We've got to use those strategies when we're stuck, and most of the time they will work. Here, you could have saved yourself those points if you didn't memorize. But you should memorize.